Hello guys, my name is Pino, and in this video we'll be going through question 6 from the November 12, 2020 N6 Mathematics question paper. Question 6.1, we have to calculate the length of the curve of the function y is equals to x cubed over 4 plus 1 over 3x from x is equals to 3 to x is equals to 4. So the formula for calculating the length from the formula sheet, so we have s is equals to a, the integral of a to b of the square root of 1 plus dy over dx squared dx. So we have to differentiate y and square it and plus it with the y before we can insert them inside this square root. So we have y is equals to x cubed over 4 plus 1 over 3x. So we differentiate y with respect to x. So the derivative of the x cubed over 4 will be equal to 3x squared over 4. And we can write that 1 over 3 x as 1 over 3 multiplied by x raised to the power negative 1. So let's differentiate that because it's easier to differentiate that than to differentiate that. So the derivative of that would be equal to negative 1 over 3 x raised to the power negative 1 minus 1, which is negative 2. So our dy over dx we can rewrite as 3 over 4 x squared minus 1 over 3. So we write that x to the power negative 2 as our denominator, and it's going to change sign. The exponent is going to change sign from negative 2 to positive 2, and we have to square this. So dy over dx squared, so the square of this, so we have 3 over 4 x squared minus 1 over 3x squared. This will be equals to, so we square this first, so we have 9 over 16. The square of x squared will be x to the power 4 by the 2. So we plus this together, so we plus the multiplication of 2 and that including this sign. So 3 over 4 x squared minus 1 over 3 x squared. Alternatively, you can expand this plus the square of this, so including that negative sign, this will be 1 over 9 over x to the power 4. So you can expand this, or you can just use this method, 9 over 16 x to the power 4. So that negative multiplied by this positive will be negative, and that 3 will cancel out with that 3, and 2 into 1 over 4, this will give us 1 over 2, and that x squared and that x squared will cancel out each other because this one is a denominator and that one is a numerator. So that x squared will cancel out with that x squared, and we'll be left with 2 over 4. So, and that negative, we must not forget that negative multiplied by that positive, it will give us this negative. So here we'll be left with 1 over 9x to the power 4. So that 3 and that 3 will cancel, and that x squared and that x squared will cancel, and it will make things easier for us. So we have dy over dx squared. So we have to add 1. So in that square root we have to add 1. So let's add it right here. Plus 1 plus 1. So 1 plus dy over dx squared will be equals to 9 over 16 x to the power 4. So negative, so let's group the like term. So this negative half plus that 1 will be equals to positive 1 over 2 plus 1 over 9x4. So let's try to factorize first this. So we have 9 over 16 x raised to the power 4 plus 1 over 2 plus 1 over 9x to the power 4. So we try to factorize this, but before we do that, we break it down. So that 9 we can write it as 3 squared, and the 4 we can write it as 4 squared, and the x to the power 4 we can write it as x squared. We just leave the 1 over 2 as it is, and that we can write as 9, we write it as 3 squared, and the x to the power 4 we write it as x squared raised to the power 2. So all of these things, they have squares, so we can just write this as 3 over 4 x squared all squared plus 1 over 2 plus, even all of these things they have, so even that 1 we can write it as 1 squared, so they all have squares, so we can write this as 1 over 3 x squared all squared. So we try to factorize this. So the factors of 3 over 4 x squared will be 3 over 4 x squared, 3 over 4 x squared, and the factors of that 1 over 3 x squared plus 1 over 3 x squared. So this will always work out like this with this question from 6.1. So this will be the factorized version of that. So in the place, and we can see that these two are the same, so we can write this as 3 over 4 x squared plus 1 over 3 x squared all squared, because we can see that this parenthesis is the same as that one, so we just write them and we square them. So most of the time it will work out perfectly like that one. So this 1 over 1 plus dy over dx all squared, we will write it as 3 over 4 x squared plus 1 over 3 x squared squared. So you can try to expand this thing so that you can see whether it will be the same as the one on top. So we have this inside the square root, so we will have this inside the square root because this is equals to that. So we have x as is equals to, and this thing is from 3 to 4. Our integral is from 3 to 4 of 3 over 4 x squared plus 1 over 3 x squared, and all of this thing is squared. So this square root will cancel out with that square, and we'll be left with the integral from 3 to 4 of 3 over 4 x squared plus 1 over 3, and that x squared is in the denominator, so we can express it to be in the numerator, and we'll have to put that negative dx. So now we have to integrate this. So we have the integral of 3 over 4 x squared will be equals to 3 over 4 x to the power 3 over 3 plus 1 over 3. The integral of x to the power negative 2 will be equals to x to the power negative 1 over negative 1 from 3 to 4. And that 3 will cancel out with that 3. So this will be x cubed over 4. This negative multiplied by that positive will be negative 1 over 3 x to the power negative 1 from 4 to 3. So now we substitute the boundaries. So in the place of x, let's substitute the 4. So we start with the bigger number. So we have 4 cubed over 4 minus 1 over 3 into 4 raised to the power negative 1. So we substituted the 4. Now we substitute the 3. Where there is x, now we substitute 3. So this is 3 raised to the power 3 over 4 minus 1 over 3 into 3 raised to the power negative 1. We use our calculator from here. 4 cubed over 4 minus 1 over 3, 4 raised to the power negative 1 minus 3 cubed over 4 minus 1 over 3 multiplied by 3 raised to the power negative 1. And should be equals to 167 over 18. 167 over 18, which we can write as 9,278. 8. And since you are calculating area, but you're not given any centimeters or millimeters, so we just use the unit square, and this will be our answer for question 6.1. Question 6.2, we have to calculate the surface area generated when the curve x is equal to y squared minus 9 for y is from 0 to 3 is rotated about the x-axis. So to calculate this surface area, we use the formula ax is equals to 2 pi integral of y multiplied by the square root of 1 plus dx over dy squared dy. So we are using this dy because our boundaries are in the form of y. So y is from 0 to 3. If you want to use the one which has x, you have to substitute this 0 where there is y, so that you can get the first boundary. It will be a, and the second boundary. So if you want to use the second boundary, then you're going to have to take this 3 and substitute it where there is y, and that will be 0. So, and it will be a second boundary. So then you'll use the formula which has the x. So in this case, let's just stick to this one because our boundary are in the form of y. 0, y is from 0 to 3. So we have to differentiate the x with respect to y. So if you want to change this to so that you can use dx, you have to make y the subject of the formula. So that's going to be a lot of work. So let's just stick to this one. So we have to find dx over dy of x is equal to y squared minus 9. So the derivative of x with respect to y, so the derivative of that y will be equals to 2y, and the derivative of that negative 9 will be equals to 0 because it's a constant, and we have to square this dx over dy according to what we have inside that square root. So we square this, so let's square the 2y, and this will be equals to 4y squared, and we have to add the 1, so let's add this 1. So what you do on the left, you also do on the right. So from here, we can substitute this 4y squared plus 1 inside the square root because that's what it is equals to. Because that's what the inside of the square root is equals to. So from here, we have ax is equals to 2 pi from 0 to 3, the square root of 4y squared plus 1. Because multiplication is commutative, we can take this y and write it here in our dy. So that's why we chose to write it here. So from here, we let u equal 4y squared so that you can be able to integrate this. So du over dy will be equals to, so the integral of the 4y squared will be 8y, and that of 1 will be 0 because it's a constant. And from here we have du over dy is equals to 8y. We multiply both sides of the equation by the dy so that dy will cancel out with that dy. So du will be equals to 8y dy. So we have y dy here, and we also have y dy, but it doesn't have the 8. So let's divide both sides by the 8. So that will cancel out with that, and du over 8 will be equals to y dy. So in the place of that y dy, we will substitute du over 8 because du over 8 is equals to y dy. So in the place of the 4y squared plus 1, we said that we'll substitute the u, and in the place of this y dy, we substitute du over 8, but this 8, let's write it there. So 2 divided by 8 will be 1 over 4, multiplied by that pi will be pi over 4, the integral from 0 to 3. Remember, these boundaries are the boundaries of y and not of this u. So the integral, the square root of this u, we can write it as u to the power 1 over 2 du. We have pi over 4 multiplied by the integral of u to the power 1 over 2, which will be u to the power 3 over 2 multiplied by, divided by 3 over 2, which we can write as 2 over 3. So this 2 divided by that 4 will be 1 over 2. And we also have this 3. And in the place of this u, we substitute back the 4y squared plus 1. And our boundary was from 0 to 3, 0 to 3. So in the place of this y, we substitute that 3. So this will be 2 multiplied by 3 will be 6. And in the place of this y, like I said, we substitute the 3. And in the place of y, now we substitute the 0. Ax will be equals to pi over 6. 6 pi over 6 multiplied by 4 multiplied by 3 squared plus 1 minus pi over 6. Oh, we forgot that the 3, so that 3 over 2. So the u is raised to the power 3 over 2. So even this 4y squared plus 1, we will raise it to 3 over 2. Even that, and even that part. So let's go back. Raised to the power 3 over 2 minus pi. 4 multiplied by 0 will be 0 plus 1 raised to the power 3 over 2, and this will be equals to 117,32. And because this is area is calculated in square, so we are not given any centimeters or meters, so let's just use unit square. So this will be our answer for question 6.2. So before we can conclude this video, so if we already have the integral of u to the power 1 over 2, so if you don't want to bring back the 4y squared, you can take these limits which are in the form of y and you substitute them here. So your new limit will be 1 when you substitute 0 where there is 3, and you can substitute this 3 where there is y, so that you can get your upper limit. So it won't be necessary for you to bring back the 4y squared. But if you want to work with that 0 and 3, you have to bring back the 4y squared back in the place of u. But if you don't want to do that, you have to change. You have to substitute 0 where there is y and 3 where there is y, so that you can get your boundary which correspond with the u. So if you have any questions, you can leave them in the comment section below. And if you find these videos useful, consider subscribing, liking and sharing this video and channel with your fellow mates.